Hello friends, this is now interesting topics, that is we'll start the exercise 1.4. Before that, some important result, that is a P implies Q is equivalent to negation of P or Q. P double implication Q is equivalent to P implies Q and Q implies P. P or in bracket Q and R is equivalent to P or Q and P or R. P and in bracket Q or R is equivalent to P and Q or P and R. Now we'll see this result. Now let us start. Now to prove the first result, that is a P implies Q is equivalent to negation of P or Q. That's why we'll first write the P, Q, negation of P, then P implies Q, then the negation of P or Q. Now first P is double T double F and Q is a TF TF. Now the negation of P is FF TT. Now the P implies Q. What implies T implies T, then it is a T. Next, T implies F, it is F. F implies T, it is T. F implies F, it is F. T. And next is, see this again here. That is a T implies T is T. T implies F is F. F implies T is T. F implies F. Therefore it is true. Now next, we'll find out the OR between negation of P or Q. That is a T or F is T. F or F is F. T or T is a T. F or T is a T. And that's why we get that the P implies Q. This is the column number 4 and this is the column number 5. These two are same and therefore the statement P implies Q is equivalent to negation of P or Q. Now see the next example. Here is a column 5 and 6 are identical. Sorry, 4 and 5 they were identical. Here is a second. That is a P double implication Q. P double implication Q is equivalent to P implies Q and Q implies P. These are the very important results. You have to remember all these results. Now the first results, that's I want to see again. What was I written? It is not the 5 and 6. It's a 5 and 4. These are the by mistake. It is. We can change it. Okay. Now next is now see these results. The first is that the P double implication Q is equivalent to P implies Q and Q implies P. And that's why we'll write it. The first is, now we'll write P and Q. The table is like this. This is the table, that is the P and Q. P double implication Q. P implies Q. Q implies P. And the AND statement of 5 and 4. Now let us start. That is the P is written as double T double F. Q is written as TF TF. Now P double implication Q. What is in the double implication? If both are the same, then it is true. Otherwise false. Therefore TT is T. TF is F. FT is F. FF is again T. Therefore, now next is implication. P implies Q. It means what implies? If both of them are same, then it is true. T implies T. Both are same. Last is same. Therefore, the first and last is T. Otherwise, what implies? T implies F is F. F implies T is T. Now see this. TT is T, TF is F, FT is T, and FF are T. Now Q implies P. Now the Q implies P. What implies Q? T implies T. Both are same, therefore it is true. F implies T, therefore again it is true. But third is T implies F, therefore it is F. And both are same, last, therefore it is a true. Now see this. And last is, that is the AND between these two, 5 and 4. Now for the AND statement, if both of them are true, then it is true, otherwise false. First two are TT, therefore it is T. Second is false. Third is false. And last is again T, because both of them are true too. Now see this. The first is T, F, F, again T. And now see this. The column number. That is the column number 3 and 6. Both are same. Therefore the given statements are logically equivalent. Now the column number 3 and column number 6, both are identical. Next is third. That is a P or in bracket Q or R. Q and R is equivalent to P or Q and P or R. Now what is this statement states? That is in this case, that is R is distributed over the AND. R is distributed over the AND. Then what will happen? Q or P or Q. And this is AND. This is AND here. And P or R. P or R. What is called this? R is distributed over the AND. P or Q. What is in between? Sign between them is AND. This AND is here. And next is a P or R. Now see this. That is why we will require these numbers 4T and 4F. What about the Q? Q is double T double F. What about R? TF, 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 TF. Now we will find out the AND between the Q and R. Now see this. Now AND. For the AND statement, if both of them are true, then it is true. Therefore, true, true, false, false, again true, false, false, and false. Now see this again. First is true, second false, third false, fourth false, fifth false, true, 6, 7, 8 are false. Now next is OR between. That is OR between first and fourth. First and fourth, OR. What is for OR statement? If one of them is true, then it is a true. Otherwise false. कमीत कमी एक तरी true पाहिजे तर true. Therefore T or T is T. Second T or F is again T. T or F is T. T or this is T. T. This will be the F. 6 will be F. 7th F and 8th F. Now see this. Now the next 6, P or Q. Now to find out the OR between P or Q. P or Q. T, T, T. Second will be T. Third T. Fourth T. Fifth T. Sixth also T. Seventh is F. Eighth is also F. Now see this. F and F. Now P or R. T, T is T. TF. Again T. TT is again T. Sixth is F. And last is F also. Now we'll find out the AND between which of the two. That is the AND between the 6 and 7. Now for the first is true, second true, third true, fourth true, fifth true. What about the next? All of them will be the false. Now see this here. All are false. And that's why the column number 5 and 8 are identical. Now the next is P and in bracket Q or R. Now what this statement tells? Now see this, very important. This is the distributive law. This distributive law is that the AND is distributed over the OR. AND is distributed over the OR. That is, the P is distributed over the OR with AND. P is distributed over the OR with sign AND. That's why we call this AND is distributed over the OR. Therefore, it is a P and Q. Or, what is the sign between them? Is OR. Is OR. And what about the next? P and R. Therefore, this is a distributive law. AND is distributed over the OR. Now, we'll prove this. Now, again, in this case, first of all, we'll write that this is the table. That's very important. The first is PQR. Then we'll require QRR. Okay. Then P and in bracket QRR. Next is P and Q. 6 and 7. And in between them, we'll find out the R. That's why we want to show that the column number 5 and the column number 8, these two are logically equivalent. Now see this, 44F, double T double F for the Q, double T double F, continue, double T double F. And for the R, TF, TF, TF. Now we'll find out the OR between Q and R. OR statement between the Q and the R. For the OR we require both of them are true, otherwise false. दोघांपैकी एक तरी ट्रू पाहिजे, otherwise false. दोनों में एक तो भी ट्रू होना चाहिए, otherwise false. First is T, second is T, third T, fourth F, both of them are false, true. Last is false, both of them are false. This is. Now next is, we'll find out the AND between first and fourth. For the AND, we require both of them are true. Therefore, TT is T. Second, TT. TF is F. Again F. Again F. F. This is. Now next is Q, P and Q. For the P and Q, again we require both of them must be true. You can find out it in this here. You can see this here, P and Q. First is true, true, F, 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 F and F. Now P and R. P and R. First is true, true. TTT is T. TF is again F. TT is again T. Third is T. Fourth is F. Fifth is F. Sixth is F. Seventh is F. Eighth is F. Now see this. Next, we'll find out the OR between 6 and 7. For OR, we require one of them must be true. For OR, we require that is OR between these two. That is a TT is T, 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 F, 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 and F. Now see this. 3T and all are F. Therefore, the column number 5 and the column number 8 are identical. Now see this 3t, 3t. Next, all 5 are FFFF. Therefore, the given statement is logically equivalent. That is nothing but the distributive law and is distributed over the R. Now the next is algebra of statement. This is very, very important. These laws you must know to prove that without using the logic truth table and prove that the statements are equivalent, show that. First is the idempotent law. That is a P or P is P. P or P. P and P is P. First is P and P. Suppose if we take this is a T. T and T. T and T will be again T. If we take the truth value F and F. F and F is F. Therefore, P and P is always P. Or if we take or P or P is again a P. Then how it is? If we take the first P, T, T or T is T. If we take F, F or F is again F. Therefore, this law is called the idempotent law. Second is commutative law. It's very again simple. That is a 2 plus 3 is 5, 3 plus 2 is also 5 in the same way. That is a P or Q is equivalent to Q or P. Or P and Q is equivalent to Q and P. It's very simple. This is a commutative law. Next is associative law. First 2 plus 3 then 5 or 5 plus 3 then 2. It's easy. Associative law. There's a P and in bracket Q and R is nothing but P and Q and R. We can change or P and Q and R. P or Q or R is P or Q or R or P or Q or R. This is a very simple rule. Let's you can know this. You must know this rule. Next is distributive law. Now this is very important. What I am saying, this statement is very important. What is important? P and Q or R. Now I am saying that here. And is distributed over the R. What is that? And is distributed over the R. Then what you will get? P and Q in first bracket. Then R in second bracket. P and R. Therefore I say that it is and is distributed over the R. See this. Next is or is distributed over the and. What is my first is or. Or is distributed over the and. Then what you will get? That is, you will get P or Q in first bracket complete, then and in second bracket P or Q. Therefore, I say here or is distributed over the and. P or Q and P or R. Distributive law. Next is De Morgan's law. This is also very important. This is similar to if the negation of P and Q is a negation of P or negation of Q. That is, and changes to or, and both of them have the negation sign. Next is negation of P or Q is negation of P and negation of Q. This is the De Morgan's law. Next is identity law. That is 5 plus 0, 0 plus 5. In the same way, that is equals to 5. Identity law, P and T. P and T, that is equals to, is there any time? Is equals to P. Now how it is? P and T, that is equals to P. Suppose this is a 5 and this is 1. 5 into 1, that is equals to 5. In the same way, that is, here is a P and T. If you take the P as a T, that is the value of this statement depends on the P. If you take the P as a T, then T and T is T. If you take here F, the truth value of P is F. Then F and T is F. It means that the truth value depends on P. Therefore, this is the identity law. That's a P and T is P. Next is P and F is definitely F. Whatever that P. If we take, जर आपण P ची व्हॅल्यू ट्रू जर घेतली, then T and F is F. F जर घेतली तर F. Therefore, next is P or F. P or F. Again, it will depend on P. If we take the P as F, then we will get F. If we take the P as a true, then it will be the P here of series. It's a P. Next is P or T. Definitely it is true. Whatever that P, it may be false or true. It's a definitely true here. This is the identity law. Next is a complement law. That's a P and negation of P is always F. Now how it is? If we take the truth value of P is a T. And what is its negation? Its negation is F. T and F. E and F. For the AND statement, we required both of them are true, otherwise false. But what's happening here? This is a true, this is F, therefore it is a F. Suppose you will say that if the P is a F, but then this will be true. Again F and T is again F. Therefore this is the complement law. P or negation of P, that is equals to T. This is also very important. If we take the truth value of P is a T, then what's negation is F. But T or F is T. Next is, this is the complement law. Next is absorption law. There's a P or, in bracket, P and Q, that is equals to P. P and P or Q, that is also. We take AND or. Next is conditional law. This is also very important. P implies Q is equivalent to negation of P or Q. And the biconditional law. These two are very important. बरेच मुलं परीक्षेला विचारतात. What is a P implies Q, that is the negation of P or Q. And the biconditional, that is a P double implication. Q is equivalent to P implies Q and Q implies P. But what is a P implies Q? Again, he is extending this rule. P implies Q, Q implies P. He apply the above rule. Now see this, I will explain. Now double conditional, that is a P double implication. Q is P implies Q. But what is a P implies Q? P implies Q is nothing but the negation of P or Q. And what about the Q implies P? Q implies P is nothing but negation of Q or P. This is. Now write the negation of the following, stating the rules used. These are the illustrative examples. Write the negation of the following, stating the rules used. The first is P or Q, and in next bracket Q and or negation of R. And the negation, we will apply here the negation to the given statement. When we apply the negation, then this will become in negation and this and will become or. Therefore, by using, this is the De Morgan's law. Now see this here. Negation of P or Q or negation of P or negation of R. This is by using the De Morgan's law. Now we'll apply the negation to P or Q. Then what is negation? Negation of P and negation of Q. This is the first. Next is negation of. In next way, negation of Q and negation of the negation R, that is original statement. This is negation of negation R. This is the original statement. Now see this again here. The first is De Morgan's law. Second is also De Morgan's law. Third is negation of, this is the commutative law. This we change here. That is a commutative law. That is the negation of Q and negation of P or negation of Q and R. This is the commutative law. Sometimes it is difficult to write on this tab, on digital board. Now see this here. Now what's happening here? This negation of Q is a common. And what is the sign in between them? These two brackets is OR. That is and is distributed over the or. That is the negation of the Q is distributed over the or. Therefore, in this case, these two are common. Therefore, we can write here that is a negation of, therefore the negation of Q and in bracket negation of P or R. Distributive law. Next is P implies Q or R. It's a negation of P implies Q or R. The first is negation of P implies Q or will become and negation of R. This is De Morgan's law. Both of them will get negation sign or will become and. Now next is negation of P implies Q. Negation of P implies Q is P and negation Q and negation of R. And that is the proof. Next is P or in bracket Q or R and it's a negation. Therefore again P will become negation and will become R and negation of Q or R. This is the De Morgan's law. Negation of P or in bracket negation of Q and negation of R. Again De Morgan's law. That is proof. Next is fourth one. That is negation of P and Q or P and negation Q. Here is a negation of P and Q or P and negation Q. Now again this and will become or and both of brackets will have the negation sign. That is the negation in bracket negation of P and Q. This or will become and negation in bracket P and negation Q. Bracket complete. Again De Morgan's law. Now the negation of P and Q will be negation of P is P and this and will become or P or negation of Q. Next is keep this and is again the negation of these two, that will negation of P or negation of negation Q is Q and that's again De Morgan's law. Next is P and Q implies negation of P or R. Now we'll find out their negation. Negation of P and Q implies negation of P or R. That is, this is equivalent to P and Q. P and Q and negation of second statement. That is the negation of P or Q. Again, this is the De Morgan's law. We'll apply the negation sign to the second bracket. This is the negation sign. The negation of P implies P and negation Q. And this can be written as, this is the commutative law. And negation of P is original statement P. This OR will become and negation of R. Now P and P is a, again it is a, by using the Associative Law, that is the Idempotent Law. Next is P and P is again P. That is nothing but the Idempotent Law. This is Idempotent Law. Question number 2. Rewrite the following statements without using if then. It means that the statements are the statements of implication. If the prices increase, then the wages rise. Let P, the prices increase. Q, the wages rise. Therefore, the given statement is P implies Q, and it is equivalent to negation of P or Q, because we are writing without using if then. Therefore, the given statement is can be prices do not increase or the wages rise. Next is if it is a cold, then we wear woolen clothes. There is a small mistake in spelling, W-O-O-L-E-N. Okay. Next is P. It is a cold. We wear woolen clothes. Sometimes when we delete something, then that get cancelled. The statement is P implies Q, and therefore its negation, therefore it's equivalent to negation of P or Q. The statement will be statement can be written as it is not cold or we wear woolen clothes. Next is question number 3. Without using the truth table, prove that P double implication Q is equivalent to negation of P in bracket P and negation Q bracket complete and negation of in bracket Q and negation of P bracket complete without using truth table. Now see this, the double implication. Now for the double implication, P implies Q and Q implies P. Therefore, P implies Q can be written as negation of P or Q and negation of Q or P. This is the conditional law. Negation of, we take the negation sign common from these two, that is a negation in bracket P and negation Q and negation in bracket Q and negation P. Then what's happening? Again by using the De Morgan's law. And this is we want to prove. Next is negation of P or Q or negation of P and Q. That is equals to negation of P. Negation of P or Q or negation of P and Q. That is, apply the negation sign to the first bracket, then it will become negation of P and negation of Q or negation of P and Q. What is the common here? Negation of P is common here. And is distributed over the R. That is the negation of P is distributed over the R. Negation of P and in bracket Q or negation of Q or Q. negation of P and, but what is the value of this? The value of the negation of Q or T is definitely it is a true, which is the complement law. First is distributive law. And therefore it's a complement law. And next is that is the negation of P and T. It depends on the negation of P. Therefore it is a identity law. Third, negation of P and Q is equivalent to PRQ and negation of P. Now in this case, P or Q and negation of P. First is commutative law. Negation of P and in bracket P or Q. Then we will distribute and over the R. That is negation of P and P or negation of P and Q. What is the value of this negation of P and T? This is the F. First bracket has the value F because P and F is F again, or negation of P and Q. Now value of this is depends on this bracket, which is nothing but that we want to prove. This is the complement law. Now we'll start the exercise 1.4. First, using rules of negation, write the negation of the following. First, that is negation of Q implies P. Therefore, the negation of Q implies P is negation of the implication. That is negation of Q and negation of P. The first statement is as it is. That is negation of the implication. Negation of the implication is P and negation Q. In the same manner, the first is as it is and second statement has negation sign. We can take the negation as common That is a negation of negation. Negation of negation. That is, we have the answer, that is the negation of Q and negation of P. This is also the answer. If we take the again negation, that is as a common, I say, that is negation Q or P. This will be also possible. Next is P and negation Q. Now we'll apply the negation here. That is the negation of P or negation of negation Q. That is the negation of conjunction, that become or. That is the negation of P or Q. That is the negation of negation. Next is third. P or negation Q. Negation of P or negation Q is equivalent to negation of P and negation of Q. Negation of Q. That is equals to negation of P. That is the negation of P or negation Q is equivalent to negation of P or negation of Q. Next is negation of disjoint. This or will become and. Negation of P. Negation of negation Q is Q. And that is true. Next is fourth one. P or negation Q and R. Now their negation. Negation of P or negation Q and R. Negation in bracket P or negation Q or negation of R. That is the negation of conjunction. Next is negation of P and negation of negation Q or negation of R. This is again the negation of disjunction. Negation of disjunction. Now here is that is the negation of P and negation of negation. That is a Q. Negation of Q is Q. Therefore, the next is negation of P and Q or negation of R. And this we want to prove. That is the negation of negation. Is original statement. that is a negation in bracket P or negation Q and R. That is equivalent to negation of P and Q or negation of R. Now fifth is P implies in bracket Q or negation Q. P implies in bracket Q or negation Q. This is negation of P implies in bracket P or negation Q. This is equivalent to P and negation P or negation Q. That is the negation of implication. Therefore, P and negation of P or that is negation of P or negation Q becomes that is the negation of P and negation of in bracket negation Q. And the negation of Q is Q. That is a P and negation of P and this is the Q. Therefore, this is going on. Now the next is negation of P and Q or P or negation Q. Negation of P and Q or P or negation of Q. This is equivalent to that is a negation of negation, and this or becomes and. Negation of disjunction. Therefore, negation of negation, that is a P and Q, and in bracket negation of P or negation of Q. That is negation of negation. Now here we will apply the negation. That is a P and Q and negation of P, negation of negation Q. That's we get P and Q and negation of P and Q. Next is seventh one. P or negation Q implies P and negation Q. Therefore, negation of P or negation Q implies in bracket P and negation Q. Now the negation of the implication. That is equals to P and negation Q and negation of P and negation Q. We will apply the negation to the second bracket. Negation of implication. that is a P or negation Q and negation of P or negation of negation Q, that is a P or negation Q and negation of P or Q. Negation of negation. And hence it is a proof. Next is 8th. Negation of P or negation Q or P and negation Q. Now again here we will apply the negation. That is negation of P or negation Q or P and negation Q. That is the negation of negation P or negation Q and negation of P and negation Q. Now we will apply the negation. This is the negation of disjunction. Next is negation of negation. That is, if you take the negation, then it becomes P and Q, and negation of P and negation of negation Q is Q. That is, negation of P or negation Q is P and Q, and negation of in bracket P and negation Q is the negation of P or Q. That is negation of again this disjunction and negation of conjunction. Next is question number 2. Rewrite the following statement. Rewrite the following statement without using if then. Therefore, here is if a man is judge, then he is honest. First, A man is judge. Second, he is honest. That is P implies Q. That is nothing but the negation of P or Q. P implies Q is equivalent to negation of P or Q. Therefore, we can write man is not judge or he is honest. Second, if 2 is a rational number, then root 2 is irrational number. Root 2 is irrational number. First is P, 2 is a rational number. Q, root 2 is irrational number. Now here is a P implies Q is equivalent to negation of P or Q. Negation of P or Q. Therefore, the statement can be written as two is not a rational number. Two is not a rational number, or root 2 is a rational number. Third, if f of 2 is equals to 0, then f of x is divisible by x minus 2. Again here, P, f of 2 is equals to 0. What about Q? F of x is divisible by x minus 2. X minus 2. Now here is a P implies Q is equivalent to negation of P. Negation of P or Q. Therefore, f of 2 is not equals to 0, or f of x is divisible by x minus 2. Question number 3. Without using truth table, prove that. Without using truth table, prove that. First, that is P double implication Q is equivalent to P and Q, or negation of P and negation of Q. LHS. Now P double implication Q. It means P implies Q and Q implies P. Therefore, P implies Q is nothing but the negation of P or Q, and negation of Q or P by conditional statement, conditional law. That is, negation of P and negation of Q or P or Q and negation of Q or P. This is the distributive law. Next is negation of P and negation of Q or negation of P or this and is distributed over the or now this and is again distributed over the or that is the Q that is the Q and negation Q or Q and P. This is the distributive law. Therefore, next is negation of P and negation Q. What about this? That is the negation of P and P. This is nothing but the F and Q and negation Q. That is called the complement law. And it depends on this statement. That is the negation of P. That is or between these two. Negation of P and negation Q or this is R. And again this is the identity law. Now it can be written as now negation of P and negation Q or P and Q. This is the commutative law. And again finally P and Q or negation of P and negation Q. Again this is the commutative law and hence it is approved. Second, P or Q and P or negation of Q, that is equals to P. Now consider the LHS P or Q and P or negation Q. That is the P or This is the distributive law and how it is. Now see this here, P. Here is a P. That is a R is distributed over the AND. This P is a common here. Therefore, R is distributed over the AND. What is the sign between these two? Here is a sign in between these two. What is the common? P is common. Therefore, P R in bracket Q and negation Q. This is the distributive law. Next is now Q and negation Q. That is F. Again, it is identity law. That is complement law. And next is identity law. P R F. That is identity law. This here you can see. Next is third one. P and Q are negation of P and Q are in bracket P and negation Q, that is equals to P or Q. Now see this. LHS P and Q are negation of P and Q are P and negation Q. That is equivalent to first is Q and P. Now by using the commutative law, and again here Q and negation of P. This is the commutative law, or P and negation Q. See this here. This is the commutative law. What would have been the Q and P or Q and negation of P, or this statement as it is. Now next is that is a Q is distributed over R. That is a Q and see this here. Q is a distributed over the R. What is sign in between them? That is R. That is a Q and in bracket P or negation of P. Next is R P and negation Q. Distributive law. Next is what is that? P or negation of P. P or negation of P. That is equals. That is T or P and negation Q. It is again the complement law. Now Q and P is a Q or P and negation Q. This is the identity. And the next is R is distributed over the AND. That is a P and Q and Q and negation. Now here is R. That is a P or Q and Q or negation of Q, and that's why pure Q and T. This is the distributive law, and here is a complement law. The value of this is a T, and that's why pure Q and T is a P or Q, which is the identity law. Now the next is, now see this, I had changed the sign. Now next, fourth one, negation of P or negation Q implies P and negation Q is equivalent to P or negation Q or in bracket negation of P or Q. Now the negation of P or negation Q is equivalent to is implies P and negation Q. Implication. That is the negation of P or negation Q or P and negation Q. I will apply the negation again and it will become AND. The first is conditional statement. Second is negation of disjunction. Negation of disjunction. Negation of disjunction. Now the next is, there is a P or negation Q and negation of P or negation of negation Q is Q. That is negation of conjunction. And hence it is a rule, that is a P or negation Q and negation of P or Q. And in this way we have completed the exercise 1.4. I hope that you will have understood all the problems whatever that I had solved. I will see in the next video. Till then, goodbye.